All right, so while people are still trailing in here, let's chat. We're gonna talk. You're good. You guys rushing up here and it's too much. You gotta chill. All right, let's talk. Which means, really, I talk unless you raise your hand. Here's the thing you guys probably are still getting used to with Phoenix. I don't even really know how to phrase this. You and how you feel about things is more important than any plan that I have made. So, my plans of oh yeah, we might go this fast, we might be able to do a unit a day, those plans don't matter if we don't feel good. Right? Because, my number one priority is at least making sure that you're comfortable in my classroom. I can't really probably fix the temperature, but, I can try to make sure that we're not moving too fast. Sorry, the HVAC joke was better at the old Phoenix because our temperature was really hard to control. So, guys, I'm going to leave 212 as, you should try it tonight, but if you don't have 211 done, that's probably a top priority is get that done or ask questions about it right now so we can do those problems together. And I've already got a problem that I picked out that we're going to do together because, 3 different people came to talk to me about it. So, if we slow down this week, which is fine, this is all subject to change. Right now, we're going to say we'll get into 212 today. I guarantee we won't finish it. I'm just being realistic. So, let's start looking at the 211 homework. And I for sure want to talk about the probability machine thing question. Whoa. Sorry, Adobe just crashed on me, so hold on a second. I am. Sorry, guys. Yeah, I did not expect Adobe to crash. So, if you look at number, I've got my binder. Number 2-11, guys. It says Nicole is a machine that will produce a number between 1 and 50. So, when we think about your sample space or the denominator of that problem, if it's producing a number between 1 and 50, I can go this way, I guess. I just don't have the answers pulled up yet. So if it's producing 1 through 50, there are 50 possible outcomes, right? 1, 2, 3, 4. Guys, if you don't have 11 done, you should be thinking about this with me. So here are the answers. Now I got Adobe to work with me. So the chance of a multiple of 10. A multiple of 10. Guys, a multiple of 10 is 10, 20, 30, 40, and 50. So that would be 5 out of 50. That's what I'm talking about 2-11. But guys, B says a number that's not 100.
That's 100%.
All of them, right? Starting at 1 up through 50, all of those numbers are not 100. So that's why this would be 100%. Or guys, you could just have 50 over 50. If you have the fraction 50 over 50, that's perfect. Not a multiple of 4. I'm probably going to pull out my dot camera and show you some of what I would write for this. What are multiples of 4? Just go ahead and start shouting it out.
4, 8, 12,
Yeah, now we're about as far as we need to go, right? Because we're only doing 1 through 50. Go ahead and sharpen your pencil. You're good. Hey guys, I don't know why I have people talking because I am fairly certain if I collected the homework right now, a lot of us would be real upset about that because I doubt that we all have it done. The tricky part here is not a multiple of 4. So if we think about the multiples of 4, those are 4, 8, 12, 16, right? We keep going. What do we have in our notes that would be really useful?
Multiplication.
Our multiplication table. So anytime you're thinking about multiples, guys, I would put this in a sleeve protector if I was you. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. There are 12 multiples of 4 before we get to 50. But then it's not a multiple of 4. So we have to do 50 minus the 12 that we just found. And that's how we get 38 over 50. There are 38 numbers in the set that are not multiples of 4. Probability of a one-digit number. What are my one-digit numbers there? 1, 2, 3, 4, up to 9. So 9 out of 50. Other questions on 11? Honestly, if I was you, I'd probably just, sorry, not 55, 50 out of 50. I'd probably make B just 50 out of 50. You can make it say equal to 1. Other questions? In 9, how do we convert fractions to decimals? We need to get that denominator to a 10 or a 100 or a 1,000. So guys, in 9, you would need to take that denominator all the way to 1,000 for part B. And then our answer to 12, got 7 and 18. On the back, I want to check the other answers probably like another day. But let's look at one other problem together. Like, I think we're going to check the rest of the back tomorrow to give people some time. Look at 2-16. 2-16 says there's some sort of pattern down here in these diamonds. Lucas, what do you think?
For the first one, 10, 5, 2, 7. 5 plus 2 is 7, and then 5 times 2 is 10. So, and that repeats with all of them.
So, you're saying up here at the top, this number is the, what do we call the result of multiplication? Starts with a P. Yeah, the product. So if you have not done this problem yet, you probably want to make a note that the top is the product. It came from 1 times 4. Whereas the bottom part, someone already shouted it out, is the sum. It's the 1 plus 4. And then to make sure that we talk about something that confused some people just because wording, a single fraction means like make it improper, right? So we can take these and make them improper. Let's review that. I want to do part C together. So if you haven't done 17C, let's do 17C together. Yeah. You got to tell me how to get to the answer. Yeah, so guys, think about this, like 2 entire pizzas and 4 15ths. Guys, I got some people not paying attention that I know your homework's not done. And that's absurd. If your homework's not done and you're ignoring me right now, you're just crazy. I don't get it. And not crazy in a good way. Crazy like silly. If we had 2 whole pizzas that were each 15 slices, we really have 30 slices from those pizzas plus an extra 4 more. So what we do here, if you forget how to convert to an improper, is you take your whole number times your denominator, add your numerator. So exactly what got described, 2 times 15. We got 30 from that. Then we add 4 more to it. This becomes 34. We keep the same denominator. 34 15ths. We'll go over the rest of that tomorrow because we're still going back into the lesson for today. So if you want to make little like notes here, the 3 is going to multiply by the 5, then we're going to add it. The 1's going to multiply by the 11, then we're going to add it. Whatever notes help you remember that. Other questions before we move on, because I will take more questions, but I know we just needed more time. Like some of us just needed more time to work on that. All right, sweet. So we were here. So either get out your notes from yesterday or get new ones, because I sort of goofed this up. Guys, I will always be honest with you. I'm clearing off my multiplication table. I'm getting blue pen all over everything this morning. I'm going to show you exactly what I was writing yesterday and what I goofed up, because, guys, when you get in a hurry, getting in a hurry is pretty dangerous. So I got in a hurry. My bad. I'll try not to do that again. All right, so we were down here on my paper. Maybe on your paper as well. And we were figuring out what to do with this division of 20 divided by 33. Here's what I goofed up. When we got to this point, and when we got to this 2, because 33 can't fit in a 2, obviously, like we just did this math to make this happen, this next 0 drops down automatically. Right? We always drop a 0 automatically when we're shifting over to the next answer spot. It was having to add an extra 0. This was an extra 0 that we put in. That's what drops an extra 0. So the note that we should really... Great. Gravity works. We need this to be heavier. Success. The note that we really need to put is that when we drop an extra 0 to work with right here, when we drop an extra 0, it puts an extra 0 in our answer. But that does not mean we're done. All because I had a 0 on my answer line, that does not mean that we're done. Ooh, I like that the highlighter is actually showing up like bright. There we go. No, yesterday's. Ooh, there we go. Those are better. Guys, continuing yesterday's notes is better than a new page. Should be less writing for you. So guys, now that the number we're quote-unquote working with is 200, can 33 fit into 200? Oh yeah, we already did this once. How many times? 6. So we put another 6 up on our answer line. And this is why I did this as a post-it, so I can do another post-it. We put another 6 up here. What do we subtract away? Same thing as last time, right? 198. Put your eyes up here. Go ahead and stop writing for just a second. I just got a remainder of 2. To move over up here, this 0 drops down automatically. Then, since 20 isn't big enough, and I have to put another 0 down here, that causes a 0 up here. It's this extra 0. Boom. Extra. That's what caused this to happen. Can anyone recognize what's happening now, though? We got 6, 0, 6, 0. Layla? It is repeating. So we now recognize repetition. Because we already did the 200 up here. And the 200 right here. We're repeating. Now, did anyone last night, it's still worth a lifesaver, did anyone last night remember how this relates to something we did in chapter 1? A mask reminder, we got a couple open noses in here. We're wearing masks over our nose and mouth. Sorry, I hate it too. Stuff's real bad right now. We got to keep doing this. I'll give you a hint. It's another fraction. Another fraction. We just said this repeats. Can anyone remember something from chapter 1 that causes repetition? John? 9 over 11. So over 11's got repetition. But to get to 11, I would need to divide by 3. I don't know if that doesn't work very nice. I'm not saying it won't work, but it doesn't work nice. So over 11 caused repetition. Do you remember another number that caused repetition? 9. 9. Could I turn 33 into 9 though?
No, you could turn it into 99, 60, 99.
Keep going. You want to tell me what this tells us?
It tells us that it can be, I don't know, 2 9s is repetition.
There are 2 9s down here. Guess how many numbers we repeat?
2. Wait, that's
2. Please write this down. Just don't worry if it doesn't make sense quite yet. There are 2, I should make this not look like subtraction. There are 2 9s down here. I'm going to write TWO. 2 9s. We repeat 2 numbers. Sorry, I should wait, make sure we got pencils done moving. So if I put different fraction, different problem, if I put 32 over 99, chat with your group about what this would become. What would this become? We just said 2 9s on bottom, repeat 2 numbers. Ooh, time for cards. I know you guys been waiting. I'm wondering when's he going to get out the cards. Probably need to shuffle. I need to hand back papers. Don't want me to let you guys go to language arts without doing it. Marina, does your group have a guess? Yeah, 0.323232 the 32.
Is it repeating multiplication?
Anytime we have 9s on bottom, just repeats. Hold on.
Is that going to be on our test?
Eventually. Dude, I'm just trying to save you a bunch of work. Anytime you see a fraction with 9s on bottom, you know what the decimal is. You don't need a calculator. I don't even think we need time to work with our group. John, what do you think this is?
4545.
Yeah, be careful. Make sure you say 0.4545.
Oh, yeah.
Now hold up. Challenge. Talk with your group, but don't shout it out. 7 over 99. Oh, maybe you guys are smarter than me. You guys are smarter than me. Deekshita, how am I going to repeat 2 numbers when I only have 1 on top?
0.0707.
This is really 0, 7. And if I needed to go on a special mission, it could be 007. Because there are zeros in front of here. They don't matter, but there are zeros in front of here. It's 070707. So guys, likewise, if you had 7 over 999, I'm trying to save you work anytime you see 9s on bottom. What would this repeat? Well, there are zeros in front of here. Nobody? Okay. It's 007. Nobody? Okay. It's dead. I'm dead too. I'm old.
No, you're alive. I see you right there.
Yeah, but if you don't know 007, I might as well just quit. James Bond. Does that help anyone? Oh my gosh, I love it. Oh, I know who James Bond is.
I know who James Bond is.
He's 007. Okay, guys, any time you see 9s on bottom, here's the rule. We'll write down one more thing, then we'll move on. The number of 9s. We can use hashtag here. The number of 9s tells us number of digits, because we've already used number a lot, to repeat. The number of 9s tells us the number of digits to repeat. Remember, hashtag is number. Trying to make sure we're all done writing. Now 1/7. Let's go ahead and try this long division with our group to try to remember how to long divide and see if we can do it right. So I'm going to give you guys a little bit of time, but go ahead and on your paper write down 1/7. Now remember we said we're taking better notes these days. So this is number 6. You can put 2-6 if you want, but I don't really like that. That looks like subtraction. 1/7. Does the 1 go on the inside or the outside? Inside. Go ahead and do this long division with your group.
Why?
Because I'm excessive. Because like my mom used to say, I'm a special boy. That's why.
That is on the social. Right now.
Nice. You need another? Good, you got it. Guys, one thing that we can remember, any proper fraction, right, where it's smaller on top than it is on the bottom, any proper fraction is going to start with this 0. Because we know it's going to be less than 1. Now, improper fraction is going to be more than 1. Only look up here if you want help/answers. Otherwise, work with each other. Ooh, I heard something. Oh, so many colors. I can't fit this on the smart board. All right, guys, even if you're still going, let's go ahead and come together to make sure that we're all doing this correctly, because there are a lot of chances for us to goof up a tiny bit. I already heard you guys saying it. I heard you. So you've got more time, so I'm going to go slow. So, I mean, feel free to ignore me. Lots of people do all the time. It's a joke. All right, so this kind of happens like automatically. Some teachers would have you write it, some teachers wouldn't. We're really looking at 7 and a 10 because it was a proper fraction. How many 7s fit in a 10? 1. So we subtract 7. I'm going to try to color code all this so it relates. Guys, watch. If you are at all struggling with long division, watch. Our remainder is 3, and automatically, well, that 0 already dropped down. Sorry, that one went there. My arrows are... This is why you shouldn't do math in pen. I should really listen to myself, but it's the only way to color code. 30. This was automatic. Nothing happens up here. No extra 0 up here. How many times does 7 go into 30? I figured you guys were already past that step. So 4 times 7 is 28. What is 30 minus 28? 2. Drop down a 0 automatically. How many times does 7 fit into 20? 2. That gives us 14. We get, I'm going to run out of colors. We get 6. Automatic 0. 7 times 7 is 40. I think it's 8. Because it's 56. This is why I had to come do it on graph paper, because I knew I'd run out of smartboard. Guys, seriously. Light blue. Drop down another 0 automatically. How many times does 7 fit into 40? 5. Which is 35, right? weird green color. Drop down another 0. How many 7s fit in the 50? Man, I need to get a soundboard in here like what DJs have. Because right now, what I want is one of those like, you know what I'm talking about? Where it's like, whoa, this is important. Why is this important? Aiden? How do you know? The first quote-unquote remainder, or whatever you want to say, the first number we worked with was a 10. And now I have a 10 again in my remainder, meaning if I keep going, how many 7s fit into 10? 1. And this 1 starts our repetition. Because if we keep going, the next number would be 4. And the next number would be 2. So what we actually see, and guys, we looked at this in chapter 1, but I only kind of showed it to you. I was like, oh, whoa, that's cool. 7 times 2 is 14. That times 2 is 28. That times 2 is 50, not 7. Sorry, it's 56, so it breaks at the end right there. But guys, 14, 28, 57. Now let me blow your mind again, because I bet you don't remember this from chapter 2 or chapter 1. Scooch down, or if you need new paper, get new paper. 2 7ths. Is 0.285714 repeating. Same numbers, same order. We just started at the 2. 3 7ths. What's the next biggest number after 2 up here? 4, right, that I have in my little set. 4, loop around. 28571. The 7ths all create this really cool little, like, there's a reason. It's because of how the long division works. I don't need you to understand the reason. It's just cool. What's the next biggest number I could use? 5. 5, 7, 1, 4, 2, 8. And you could do the rest of them the exact same way. 5 7ths will use the next biggest number. And guys, if you did any of the long divisions, it would support. It would do exactly what we just saw happen. All right, cool. That's just kind of fun. And it was a good way to review how to long divide. Moving on. So, let's make sure, I was really debating, and with the amount of time that we have left, draw a squiggly line, you might want to start a new piece of paper. What? Guys, I'm trying to teach differently this year. So, like, we've only got like 8 minutes left of class. So, if you feel like this is simple, take a nap, whatever. The denominator, and honestly, I should be careful underlining it. The denominator is the bottom of the fraction. Right? So, it is this number. What's it tell us? Antonella? How how many pieces something has been split into. So pieces, how can we say that differently? Pieces, yeah, like pieces needed for the total, right? Like pieces needed, I can't spell, yet. And another way to say total, pieces needed for a whole. So guys, the first problem on your homework last night was asking how many tenths does it take to make a whole? How many hundredths does it take to make a whole? And what it was really pushing you to think about was if the number on top is the same as the number on bottom, that's like the entire pizza, right? So if my pizza is cut up into 100 slices and I have all 100 of them, I got the whole thing. So anytime we have less than the denominator, we're going to have less than 1. And anytime we got more, we're going to have more. Right? So proper fractions, where the number's less, tell us we'll have less than 1. And that's why we were doing that long division. Because after this chapter, I'll probably never ask you to long divide again this year. Because it's, I mean, you can if you want. Hold on, we got 5 minutes left. So real quick, if you want to review your vocab, a mixed number uses both the number and the fraction. A fraction bigger than 1, improper. I actually like improper fractions a lot. I dislike that we called them improper because it sounds like they're bad. They're great. 13 over 3 is way better than trying to write that as a decimal. As a decimal, this would repeat and go on forever. That's kind of bad. Right? So improper fractions are good. And then regular, just normal fractions are proper, where the number on top is smaller than the number on bottom. Let's make sure we at least look at tomorrow's lesson so we can say we quote-unquote started it. So the portions web. A portions web is a like CPM name for just a a nice visual way to show these 3 representations and a verbal. So guys, here's what I got to tell you with your homework. Yes, I want you to write the words. I don't care if you do the web. Right? Some people say, can I just write this equals that equals that? That's fine. So for 7/10, we could do the web, or write down on your paper 7/10. How would we write this as a decimal? 0.7, right? How would we write this as a percent? 70%, right? Because this would actually be 70 over 100. I don't know why I got some people not with me. I still got 4 minutes of class left, and I plan to use them. So really, that was 70 over 100. 70%. And guys, to write it in words, we can just say 7/10. It's that THS on the end, right? That really tells us we broke things into pieces. So you cannot do nothing for the next 4 minutes. You can get out your homework and discuss it with your partners there. You have 4 minutes to talk about your homework with your partners. Last night's homework, tonight's homework, I don't care. Put a little bit of time into your homework. I guess we could do another problem together. You guys want to do a problem together? Someone throw one at me. Ooh, let's look at 13. 2-13, if you want to do one with me. 2/5. Can it become something with a 10 or 100 or 1,000 on the bottom? Yes. By doing times 2. So we get 4/10. Does that mean it will terminate or repeat? Terminate, because we could just write that as 0.4, right? 4/10. 7/45. So I'm writing up here, even though we're doing this one. There's more space up here. Man. I could make it 90 to be times 2. Or so I could make it 14/90. Can I make that into a 10? Can I make that into 100? Can I make it into a... It'd be kind of hard to make it into 100, right? Could make it into 1,000 maybe? I'm not sure. This is feeling like it might be a repeater. What did we just say in our lesson if we look at C?
99.
About anything over 99. It will repeat. What did we say 5/99 would repeat as? 0505 repeated. And could 250 turn into 1,000? Yeah, 250 could turn into 1,000.
0.4.
Alright, pack it up and head out, guys. So, you know you can resume the big back. The problem is just on the back. That is this problem. You explain why you take the time to do that problem with us. And I said, hey, we're going to do this problem together. So, get here and write down what I wrote. You can go to language arts and you write down everything that I have written down in class because you go back, you're organizing the problem. And that's not okay. Katie, I think I may need to start choosing where you sit. I think I'm going to give you one more day to have the opportunity to sit where you want and show me that you can handle it. Otherwise, I got to choose your seat.